So the subtitle here, Many Meanings of Map. I've found myself a couple of times now, I get clever subtitles, after I've developed the talk, after, presenting the paper. So we'll be talking about mapping and meanings of things like that as we go along. The obligatory who I am, ways you can contact me. I want to thank my company, Seat Scouts, who sponsors this trip, who has, paid me to work in Elixir for a couple of years, and it's been a great time, and I'm loving it. So, without further ado, starting with people first get introduced to Ecto, their first thought is, what is it? What is it? Is it an ORM? And that's when you can pull kind of the, well, technically, there's no objects here, so, we can't count the objects, So Ecto is like, it's an RM. Yeah. Well, for this talk, to fit it in our time slot, I kind of, in slimming things down, we're not talking about the relational database side of this. So for purposes of this talk, Ecto is an M. It's a mapper, and many meanings of map. You might even say that this talk is sponsored by the letter M. So the hex docs for Ecto tell us it has 4 main parts. And the Ecto repo, that's cool stuff. That's cool stuff. But it doesn't fit here. We're not talking about that. Ecto schema. Yes, it even tells us here it's often used to map tables to Elixir data, but it's not a requirement for using Ecto. So that's kind of the special place that we'll be talking about here. Change sets. Love change sets. They're a great use of a pattern that I'm finding myself using more and more with Elixir, which I'll get into more as we go. And then Ecto query. Yeah, really cool stuff in there, but out of scope. So I want to start out, I love live coding. Watching people live code, it's really cool. But I decided I'm going to give you slides because I don't know if it would be you or me more frustrated with watching me backspace so many times. But if you want to play along on your laptop, this is the way I set up the environment, and you'll see that there's no databases involved. I'm going to show a little bit of Phoenix stuff, so I used a Phoenix generator here, but no Ecto. Then I add into the depths. I add Ecto, but not Ecto SQL, which has recently been split off, where Ecto has those 4 parts we saw on the previous slide. Ecto SQL has more of like the database connection pooling management and migrations and these sorts of things that are very tied directly to relational databases. I use Phoenix Ecto also because it's a glue project that takes features of Ecto that can be loosely coupled into Phoenix by implementing protocols. So we'll talk about that briefly. And then, of course, you do your mixed depths get and bring up your IEX session. And that's all that we really need for any of this stuff I'm showing today. So every journey starts with a map. Maps give you lay of the land, let you kind of know your bearings, where you are. So I'm going to want to talk a little bit about what the pieces are at a low level. I always find it helpful to learn things like one level below the area that I'm focusing on. It gives you, even if you don't know all the details, knowing the implementation a little bit gives you intuition about what's possible. And it gives you ideas on how to troubleshoot when things go not as you expect. So we're going to look at a few things that are implementation details, and I'm not suggesting everyone write production code like this, but understanding it and poking around in IEX has really helped me a lot as I've been coding with Ecto and overall in Elixir as a whole. So we'll start out. Maps are also, a data structure. They're called different things in different languages. Maybe you've heard of dictionaries or hashes or associative arrays if you speak Perl. And in some ways, a map itself is almost a pure function. If you squint just right, you have a key that you're given as a single parameter input, and it's going to give you an output, the value that's mapped to that key. You will get that all the time. You call it over and over again. It's just an enumerated list of inputs and outputs. There's no algorithm. It's like a pure lookup. And one cool thing about Clojure is it treats maps as a function. You can actually call them as a function, pass a key in as the parameter, And that's just like doing a map lookup. So maps are really cool. They're really fundamental to a lot of the things that we do programming-wise. So structs take maps and add even more to them. Structs give us superpowers. If I recall, structs were added almost the same time that OTP map support dropped, and the core Elixir team wanted to really have the struct stuff layered on top of it almost at the exact same time. There might have been a release in the middle, but they really are closely tied in Elixir. And so I want to look at some basic anatomy of what makes structs different than maps. This is shorthand syntax. Don't write your production code like this. But in IEX, it makes for a nice one-liner and not a lot of room on the slide. A simple def struct with 3 default values, because I was very clever calling them A, B, and C. But IEX gives you back the binary form of that. And then you like to inspect things. That's what I do half the time. What I'm doing in IEX is inspecting what happens. And surprise, it looks like a struct. Well, it ends up there's an inspect protocol that structs implement that gives you this special display. But we can actually pass a parameter to inspect to turn that off. So this sort of structs false thing is the way to kind of peel back the curtains a little bit and see what's going on a little bit lower level, especially when things are going wrong. You can kind of peek inside a bit more. So what do we see here? It's added another field, double underscore struct, double underscore. And that field points back to the module that had the def struct. Well, that seems kind of handy. You've got the data structure and you've got the module that defined it, and you can go bidirectionally with those things, but it hardly seems like a superpower, does it? Well, let's look at a little bit more behind the curtains thing. We have this double underscore info double underscore, which is, this is getting wordy. I'm going to be talking about lots of these double underscore things, and you know how some people like to do like finger quotes, you know, this is this finger quote, and I had some folks I worked with that had like angle brackets. So I'm going to do double underscore, okay? So I'll just do the hand motion and not have to spend all those extra 10 syllables saying double underscore twice, okay? So in the info function that's attached to every module, which is documented in the module hex docs, you can find out what public functions are exported on that module. So here we see we have struct, 0 and 1. So not only did it add a field in the data structure, it added some more functions on the module. So let's poke around, peel the curtain. What happens if we call that function? So what we get back here is basically just as if we had called the regular this regular constructor with %a curly brackets. So this is like the lower level piece. You really should never call this sort of thing. You should use the other syntax. But we see here that it's effectively the same thing. This applies the same default values. It all does the same stuff. The struct1, array1 function takes in a map or keyword list and assigns those, overrides your defaults, basically. And that's the thing that yells at you if you try to assign a key that's not defined in the struct. So overall, what the structs let us do on top of maps is actually restrict them. It's a way of saying just these keys are supposed to be here. There's ways around it, but I don't recommend it. But that's what all these struct mechanisms are set up to do. So we start with structs. That's kind of what Ecto is all about, mapping structs to structs. But all these structs are maps with some extra field and some extra functions on their module. So let's move on. Here we get to real Ecto code now, schemas. Schemas are like another layer on top of those structs. So now we have like 2 layers of superpowers here, okay? So let's look at, I'm going to use an embedded schema. That's what we call the things that don't map to relational database tables. So, okay, screen, okay. Again, this is a squeezed for space on the slide way of defining the module. So it's module B. Again, clever naming. Its field A is an integer, B is a string, and C is a float. So here we're able to add in type information for what each value is supposed to be. So let's see how this performs its magic. Peel back the curtains a little bit here. So we'll do our inspect with our, bypassing the struct inspect protocol. And we see here, look, we get that struct field. We already got that from struct behavior. We get an extra ID in here, and that's because I didn't turn primary key off. I was lazy in IEX. It won't hurt it to be here, but surely schemas do more than just add in a primary key by default, right? So we can go back looking at our module info function for the functions and look at all the goodies that the embedded schema macro adds to our module. We got the familiar struct 0 and 1, but now we have schema 1 and 2, and we have this changeset 0. Interesting. Let's poke around. What's here? How does this work? This underscore schema, it actually is documented in the Ecto schema hex docs. It lets you introspect and see some of these things, and it enumerates which values you can pass into it. You can get fields, you can get associations, I think you can get like primary key. You can look at how your schema was defined. And so this tells us, oh look, we have ID, ABC. We knew that, but now it knows it too. And it's able to carry this around with any instance of the struct or the schema has a reference to its module, and that module has these functions. So just the bare data structure can be passed around, and you can know how to invoke all the proper behavior on it. We can go a little further here. Yeah, the changeset 0. This is the fun one. If we look here, it gives us back a map. There's maps everywhere. But this map tells us key names, field names, and their types. So this is carried around very succinctly in every schema that we define. And we're going to come back to this. We're going to see this again. Notice this is schema. This is not changeset. But clearly they're related. And let's move on to changesets. That's what's coming up next. Changesets are coming out. Okay, well, technically. There's good things to learn from object-oriented design patterns. We changed some terminology around, but this is a pattern I'm seeing more and more in my own Elixir coding, and I'm seeing in other libraries as I'm peeling back curtains a bit. You've got the plug connection, which is a struct that you kind of pass through a number of operations and build up the entirety of the command that you want to execute. And then you execute it. So it's a way of building up these instruction sets and executing. And changesets are like that. They're going to tell us the instructions of what it means to validate a mapping from one map to another. Okay, dig in. Peel back curtains, a little bit more IEX time. What does a changeset look like? Just in the basics. Notice I'm not doing anything fancy to create it. I'm just using the plain constructor. Just want to poke around, see what's there. You see 5 fields. Okay, that's nothing too crazy. But then when you turn off the inspect protocol, it ends up, changeset has its own implementation of inspect protocol and doesn't even show you all the fields. All the ones in black are kind of the added ones. And it's documented in the changeset docs that there's like 3 of these that they say, these are private, don't touch them. So that tells me there's this other set in between that's kind of like for advanced users, if you know what you're doing, maybe you got something you want to do with this. It makes sense. Be careful, because we don't show them to everybody, but there's some things you can do. So it's interesting seeing what all it's carrying around. So actually, there we go. Let's actually create the change set in the proper way, right? So I'm creating an instance of, you remember my cleverly named B schema? Setting value A to 0, but I'm going to change it to A, add 2 other fields. And I'm leaving C off as out of the allowed values, that third parameter, the allowed fields. So we get back, in the simple version, you kind of see, look, we're going to change A to 1 and B to Lonestar. Isn't that cool? But then when you peel back a layer deeper, you see all the other things it keeps track of. You see that it actually has the data of the struct that you passed in as your first parameter. It has the params. It stringifies the keys, so it puts them in a consistent fashion. It stores internally exactly what you passed in, so it knows what you asked for. And it has the types. It was able to pull that off of the module that implements the struct that was the first parameter, because we saw that Changeset function earlier. It's that same information. So Changeset sucks that out, keeps it inside of itself. If you were to add validates length, of B, max of 20 or whatever, you'll see some things added to validation fields here. I encourage you to kind of go in and poke around and play with this. And next step is, okay, this is the cool part here. Apply action. This is like I was saying, you build it all up, and then you execute it. And if you look, nothing up my sleeve, no database in sight. You're getting the same sort of interactions you're used to with a repo. If you do an update on a repo, and it gives you back an OK in the valid struct, or it gives you back an error in a change set. Part of repo code is actually going to be calling this, and this is what tells the change set. Apply action is what tells it to do its thing. We've built up all these commands telling you what to do, and now do it. So in my second example, I like pi, but it's not an integer, just so we can see what an invalid result is when you do the apply action. And you can do apply action, insert, update, delete. I mean, there's a few of them, which really for embedded schema don't make a whole lot of difference. You could probably use whichever one makes sense to your particular domain logic. So we've taken a map, turned it into a struct, turned it into a schema. We've built a map of what the allowed keys and values are. We have taken an input map, and we have mapped those onto the data. So you can see there's lots of mappings going on. The many meanings of map is really coming out here. And you guys are all hearing Elmo's voice right now, aren't you? It's in your head. You're welcome. So let's step along a little bit more, and kind of another layer of power, superpowers, given to these change sets, which are both structs themselves and maps, and therefore maps. Phoenix protocols. This sounds to me like the next Hollywood blockbuster action adventure, right? I can picture Chris McCord as Tom Cruise or something, or vice versa. But this is in the Phoenix Ecto package, which adds some of these extra protocol implementations. So the two packages are loosely coupled, and this one is the thing that kind of brings them together by implementing these protocols. And I won't go into the details of the second two, but this first one right here, change set, Here, we're going to add another power to change sets. This is going to be like a disguise, like a rubber nose and glasses. It's going to let Tom Cruise disguise himself and be a super spy or something. So let's look a little bit at how that is used and how that's implemented. Back to IEX here. I've taken that error change set from the last slide. So we tried to set pi, and it says, nope, that's not an integer. And ultimately, in your views, you're going to be calling this HTML form 4 and passing it in that change set. So we know kind of what's in the change set, but now we can see how this form struct wrappers that, and how that information can be copied from one to the other and get used properly. If you'll notice, for example, there, we have the data, which is actually, we know change sets hold that data, the struct, and originally what our starting values were. We see in the form struct the params, which we know the change set holds those params with stringified keys that we originally passed into it. And we can see that even our errors got copied over. So now all of our HTML form helpers have something they know how to work with, but they're not working strictly with change sets. change sets know how to convert themselves to something that can work with. So that's kind of peeling back covers, understanding how these change sets are even used at this layer in Phoenix. Okay, I want to move on to a couple of examples worked out. That, a lot of this was kind of behind the scenes. Let's understand one layer below what we're talking about, and now let's actually do something, right? So this is sort of a little context here. At my company, we deal with events, but not like events is an overloaded word. These are like events you buy tickets to. So concerts and sporting events and theater. And so we have a lot of these, and people like to search on them. So this is an example of how we could offer an advanced search, but do it in a safe, struct-based way. Instead of just accepting whatever garbage comes in params, we want to put structure on them and not have a bunch of conditional if statements and what if this field's not here, what if this value is not what we expect, or the type we expect. So in that ... part, I'm going to jump back out a little bit into IEX. Okay, it's a great place for exploring. So I got query params here that might be the types of things we allow searching for. Okay, barbecue is a competitive sport in Texas, so maybe people want to search for barbecue tickets, right? So we have name, city. We've got start and end, which I've cleverly made an ISO formatted date string. And I've defined those types. This was the same sort of stuff that we got out of that Changeset function that got added to our module by a schema. But here we can do a schema-less change set. This is so simple, I just decided not to actually define a schema. If you look at the first parameter that gets passed into the change set cast, it's a tuple of 2 elements. You've got a dummy map, and you've got those types, which is basically the same information that the schema's struct carries into the change set. You're explicitly giving it the types instead of it reading it from that injected function. I pass in the query parameters, and I just let all the keys of the types be allowed fields, and boom. Look, this knows the changes. It even knows, because of Ecto has a custom date type, and it knows how to convert those ISO formatted strings into actual Elixir date structs. And it pretty prints them with a little sigil here. And any custom Ecto type that you need to write for your domain would also be usable here in the same fashion. This gives you a really powerful way of just kind of, hey, I want to make sure what this user gives me has these keys, and each of those keys are of these types. So kind of blending it, oh, sorry, got ahead of myself. Digging in a little deeper, just kind of turn off the custom inspect protocol, and we can see that this carries the params as we gave it, and the types. So the change set does store the types in the same place in the change set, but normally it pulls off the struct itself. Instead, we just give it to it, and change set can go on and still do all of its same things. We can even add validations to these fields if we want to. And then we go and do our old friend apply action, no database in sight, and we get back an OK and a struct. And now we're ready to have confident code that knows what's in this input for searching. And you don't have to put in a lot of conditionals, if statements, worry about too many corner cases. You kind of can make your domain logic, the part of your code that makes your code special, can be simpler, and you keep all the nasty, ugly corner case stuff out over here. So this can fit back in your code, something like this. And this is like one layer. You can add this as a certain first time you need this. Do something simple like this in your controller. Notice we have that simple little cast params helper function. Yeah, just kind of 3 lines. I think there's whole hex packages out there that validate your stuff that perform basically the same stuff. Again, you could put more validations if you want to. You want to make sure that the start date is not earlier than today. because nobody wants tickets for an event that already passed. You might want to make sure that the end date is no more than 6 months after. You know, you can do all these things. If you end up with a lot of validations, then you may want to make a separate schema, embedded schema module, and not do the schema lists. But it's a real easy transition. And all of your other code in my cleverly named, not in scope for this talk, module, receives these query parameters in a way that it can have confidence in what's there and what types of things are there. We're really kind of doing like optional typing. We're able to take parts of our code that need to be a little bit more rigorous and restricted and put it in where we need. It's not like full static typing where your whole system needs it right up front for anything to compile, anything to run. You have the option to decide how much your system needs at what part of your system. And I think that's all for this example. Yes. And if we take this even just a little bit further, again, design pattern stuff, you know, domain-driven design, lots of talk of a lot of things that are irrelevant for functional programming, but I think this in particular, anti-corruption layer, does make a lot of sense. It's the idea that you keep the corrupt data, the ugly part of the world over here, and it has to pass through a gate before it gets into your nice, clean core domain logic so that that code can be written confidently and clearly and get your stuff done effectively. So I'm going to kind of build up, again, not every system will need a whole lot of this. You can build it up to the layer that makes sense for your application. So little box and lines picture. The idea here is something in your domain logic is going to query the outside world. It's got some API client, something somewhere that's going to talk to that big, ugly, corrupt cloud over there, right? And that's going to give you back some information. In our case, like my example, for events, we even need to pull events from multiple places and then make them all fit the same shape for our internal logic. It goes through the anti-corruption layer that kind of makes sure, you know, are these keys here? Are they holding the right kind of things that all of our core logic depends upon? And that layer gives you back those type structs to your domain logic for further processing. So this is like a beginning example type of thing that would make sense for us dealing with events, you know, ticketable events. I've simplified things, but we got a few fields here, and I chose to call a function new. It sounds a little O-ish, but it kind of made sense to me that this is the way to create a new one. You pass in the params type of map that you want to do with all your ectos, and this is able to do the cast, and then it does an apply action. So again, this is like that helper function we had in our controller earlier. This is able to get us back that struct with very little fuss or muss. Or it gives us back an error change set. And our application decides, oh no, this really needs to, you know, let it fail, or maybe we need to log it, or, you know, something like that. Or maybe we just skip it because we have a whole list of these things and we'll skip the ones that fail validation. It's up to you. Now, in our case, it's actually not quite this simple. We have like a rich tree of these structs that we build. For example, events have venues and have performers, and you can kind of imagine this. We've probably got over a dozen of these in our system that we use in various routes that we start with. So this gets a little bit more complex here, right? Because now we have to do like cast embeds of these other embeds one that we add to it. And so what we have here, this is broken code. This isn't going to work. Cast embed is going to have to call Changeset on that subsection of the map you pass in, of course. So you've got a string called, in this case, venue, expects it to have a map. And the Changeset knows it because it keeps a record of everything we gave it originally. And so it can pull that value and call Changeset on the venues schema. And that's kind of how the trees trickle down. Well, if we do all these kind of consistently, and we're just using new, we don't get that Changeset. So that's when it makes sense to go one step further and break things up And I've taken what was done as new, split that into a new and a change set. So a change set, you're probably familiar with. This is the same sort of, hey, we're going to cast, and here's the allowed fields, and we're going to validate these things, cast embeds. And if we do this same sort of splitting between change set and new in all of our embedded schema modules for our domain logic, we get consistency. We can create any one by itself, or we can create any one as part of a larger tree. So now the whole job of new is to kind of create the empty module, change set it, and then apply our action. 3 lines of code, pretty simple. Now, you end up with some duplication here. So we can even take this another step further. Not everyone needs to. In our case, we're doing a lot of this, and we decided to do that. And you add meta to the front of anything, and it makes it sound cooler, right? The first rule of Macro Club is don't write macros. So we haven't so far. But now, I think it makes sense to put in a little bit of meta programming here. This is kind of the desired output, the desired result that I'm looking for here. And something that we've achieved in our code base. We're using our custom module here, what I've called anti-corruption schema. And that's where all the magic's going to happen, right? We only use fields and embeds. If you use other types of relationships, things will be a little more complex for you. But to fit on a slide and for what I'm familiar with, that's kind of the scope of this example here. So I hope this is not too much of an eye chart. This is the worst it's going to be. This is the most code on one slide. But this is the whole thing. This is like, what, 20, 25 lines of how to get a meta-programmed anti-corruption layer. And we'll walk through it piece by piece. So as most of you know, when you use a module, what that means is you're calling the using macro in that module, right? And what this is able to do now is inject code in that calling module. So our event performer venue, for example, is going to use Ecto schema. We're going to turn off primary keys because I said that was wise earlier, but I didn't bother with it in IEX. And then I'm adding 2 functions, defining a new and a change set that basically are just wrappers that call the anti-corruption schema's generic versions of those 2 things. There's a little bit of funniness there. The new that we define is arity 1, but it calls the generic new of arity 2 because it needs to actually know the module that is calling it. So the event, performer, venue, actual module will be passed in via metaprogramming. So generic new looks just pretty much like the new we had before. We're calling kernel struct with that struct module. So now we can create an empty version of that module. And so we can call changeset on that module, which is typically going to be generic changeset. But because we're def overwritable, if you need to, you can overwrite it. It can call the generic one and add some more validations. So it gives us a way that any of those that have more complexity can add that easily. And then it calls our good old apply action. This is the no database transaction, boom, struct in, struct out. Now we know what's in the struct, what types of things we got. Generic changeset gets, now we're doing a little bit of introspection here. All that time I spent in IEX peeling back the curtains becomes really useful here because you know that this information is here and you know kind of how to get it and you need to do it responsibly. And walk you through here, I know that base that's getting passed in here is the struct module, the embedded schema module, right? So this would be event, performer, venue. And I know that because it's a struct, it's going to have a struct field on it. That's going to tell me what the module is. So I can get from data structure to its managing module and vice versa. I'm able to use the schema function that the embedded schema injects onto that controlling module, find out which fields are embeds fields, and what the total list of fields are. And since, in our case, we're only using those 2 types, I can subtract the embeds from the total list of fields, and these are going to be all of our allowed fields. right? I can kind of meta-program this for any of my embedded schemas that we define in our project. So that gets me the initial cast. Then I reduce over all the embeds, which is then going to effectively call Changeset on each of those, as we talked about, and build the Changeset as the accumulator of that reduce loop. And so we're back and are able to write kind of simple code here. We can add new structs as we need. And this has been working great for us. So this is kind of really where this was my inspiration. This was so cool. Ecto can do all of this. It doesn't need a database. It's mapping your data from, you know, the Wild West, that corrupt stuff from out in that crazy cloud, and into something that you can write confident core domain logic with. And how are we doing on time? Really good. So maps are structs are maps. Schemas are maps. They're all building up behaviors to these. Change sets are maps. We're using these maps to perform mappings from one map to another map. It sounds funny, but these are really powerful in understanding each one, which fields they have, and how to execute the change set. Really gives you this power of using Ecto in, you know, possibly a new way to many of you. I also recommend you understand what's going on, like, you know, just a layer below. It allows you intuition to say, hey, this sort of thing should be possible. And you play with it, and you're able to save yourself a lot of code. It makes coworkers more confident adding in new versions of these types as our domain logic calls for it. They're not needed for everything. It's up to you, your system, just how important it is to control where you want to restrict that incoming data. But you've got your power to do it easily wherever you need. It's like runtime type safety, but it's just in whichever parts you feel the need for type safety.